Today we're moving on to section 2.4, other types of equations. Section 2.3 is just a lot of applications. It's a lot of word problems, and they can be pretty difficult. Plus, they're really tedious to work through. So we're just going to skip that section and move on to the next one. So our first type of other type of equation, I guess you would say, is the absolute value. Definition of absolute value: the absolute value of a number c is denoted the absolute value of c and is defined as follows. If c is greater than 0, then the absolute value of c equals c. So if c is a positive number to begin with, then the absolute value of the positive stays positive. If c is less than 0, then the absolute value of c equals negative c. So if c is a negative number, then the absolute value of c is the negative of a negative, which makes it positive. In other words, I have negative 5, which is less than 0. Then the absolute value of negative 5 is negative of a negative 5, which gives us positive 5. Absolute value of 5 is just 5, and absolute value of negative 5 is 5. Absolute value in distance. Distance is measured in absolute values because it cannot be negative. If I walk outside my door, so I open my door, and I look to the left, and I take 10 steps to the left. Is that going negative 10 steps? No, I still went 10 steps. It's not like I went backwards or forwards. None of that makes any difference. I'm still going a certain distance. I can walk from here to Ambridge backwards. I didn't go a negative distance. I still went a positive distance. That's because distance is measured in absolute values. It can never be negative. So if c and d are real numbers, then the absolute value of c minus d is the distance that's between c and d on the number line. So the distance between 3 and 6 is simply, if I do absolute value of 3 minus 6, that equals 3. Absolute value of 6 minus 3 equals 3. Doesn't matter which direction I go. It's still just my distance because it can't be negative. So the absolute value makes it positive, and it's going to stay positive. Think of it this way. I leave my house, and I walk 3 blocks to your house. So I went 3 blocks, right? When I go home, if I walk home 3 blocks, I didn't go negative 3 blocks. I still went 3 blocks. Think of this as a 3, and this is a 6. If I'm going 6 minus 3 back this direction, it's still 3. Make sense? Get better. Properties of absolute value. Let c and d be real numbers. So they can be any numbers that are real, not imaginary. Then the absolute value of c is greater than or equal to 0, always. And the absolute value of c is greater than 0 as long as c is not equal to 0. Absolute value of c is equal to the absolute value of negative c, just like when we were looking at 5 and negative 5. Those ended up being equal when we take the absolute values. The absolute value of cd is equal to the absolute value of c times the absolute value of d. In other words, if I was to say c is negative 3 and this is 5, then the 3 times 5, negative 3 times 5 gives you negative 15. Absolute value is positive 15. And if we do the absolute value of c, which would be negative 3, that would give you positive 3 times a positive 5, which is still positive 15. It doesn't make a difference. Same thing with division. If I have the absolute value of c over d, that's equal to the absolute value of c over the absolute value of d. And d cannot be equal to 0 there because we can't divide by a 0. That takes us to the triangle inequality. For any real number c and d, the absolute value of c plus d is always less than or equal to the absolute value of c plus the absolute value of d. If I had c being 6 and d being -4, and I plug those in, 6 plus -4 has to be less than or equal to the absolute value of 6 plus the absolute value of -4. This will always be true. This is the one scenario where it's going to end up being different here. If I do 6 plus -4, that gives me 2. Absolute value of 2 is less than or equal to absolute value of 6 plus absolute value of -4. Absolute value of 2 is just 2. Absolute value of 6 is 6. Absolute value of -4 is 4. So 2 is less than or equal to 10. So that is true. Wouldn't matter what numbers I plug in for C and D, this is always going to end up being true. Let's say I made those both negative. -6 plus -4. This gives me absolute value of -10, which makes that positive 10. Absolute value of -6 is 6. Absolute value of -4 is 4. So that's 6 plus 4. 10 is less than or equal to 10. They're equal to each other. So it's true. Positives are even more general. 6 plus 4 is 10. Automatically take the absolute value, stays 10. Absolute value of a positive 6 is still 6. Absolute value of a positive 4 is still 4. So we end up with 10 less than or equal to 10 anyways. We also have square roots of squares. For every real number c, if I square it and then take the square root, that is equal to the absolute value of c. In other words, let's say I have c equals 4. If I take 4 and square it, that gives me 16. Take the square root of 16, that equals 4, which is the absolute value of 4. Additionally, if I had plugged a negative in, c equals -4. The absolute value of -4 squared, the square root of -4 squared, that's equal to the square root of 16, because a negative times a negative gives you a positive, which is just equal to 4 again. And 4 is equal to the absolute value of -4. So those two are always going to be equal to each other. Example 1, using absolute value and distance. Solve the absolute value of x minus 4 equals 8 using absolute value and distance. So the way that we do this is we're saying the difference between some point x and 4 is 8. So if I have some number 4, then I can go 8 away from it, right? And that would take me to 12. But I could also go 8 in this direction. 3, 2, 1, 0, -1, -2, -3, -4. And so just by looking at this, I can see that it's true. I'm 8 away here, and I'm 8 away here. If I plug those values in, 12 minus 4 is 8. Absolute value of -4 minus 4 equals the absolute value of -8, which is 8. But we don't want to draw a number line and go the distance each time, right? So it's best if we figure out how to do this. Well, the way that we can do it is we can remove our absolute values and set it equal the same way it is, and then set it equal to a negative. That will give me my two possibilities. Now if I add 4 to both sides, that gives me 12. If I add 4 here, it gives me negative 4. So I end up with x equals 12 and x equals negative 4. That's how we're going to solve all absolute value equations. Remove the absolute values, and there's going to be two solutions. One with the same as it is now, the other one using a negative solution. Example 2, using the algebraic definition of absolute value. So when we use this definition, I swear I just took a drink and I was already. When we use this definition, what we need to realize is that it doesn't matter what's really in our parentheses or in our brackets here for the absolute value. Whether it would be negative or positive, it would still give us the same answer. And so we treat it that way. We do x plus 4 equals 5x minus 2. And then we do negative x plus 4 equals 5x minus 2. Now I just solve. I'm going to subtract the x over. It gives me 4 equals 4x minus 2. Add the 2 over. It gives me 6 equals 4x. X equals 3 over 2, or 6 over 4 reduced. On this side I have a negative, so I can distribute that negative. It gives me negative x minus 4 equals 5x minus 2. Add this x over, gives me negative 4 equals 6x minus 2. Add the 2 over, gives me negative 2. So 6x equals negative 2. Divide by 6, that gives me x equals negative 1/3. In these questions, some solutions do not make the original equation true. We can check that by substituting back into the original equations, and these are called extraneous solutions. That's why you should check every question. If I plug these two solutions back in, 3 halves plus 4. In order to do that, I have to get a common denominator. That would make this 8 over 2. Equals 5 times 3 halves minus 2. 3 plus 8 is 11 over 2. Multiply this out. You just multiply 5 times 3. That gives me 15 over 2. Then in order to subtract this, I need to put it over 2. So I'm multiplying the top and bottom by 2. 15 minus 4 gives me 11 over 2. First solution works. Now let's check the second solution. Negative 1/3 plus 4. Again, common denominator. So I'm multiplying top and bottom by 3. That becomes 12. Equals 5 times negative 1/3 minus 2. This is going to give me 11/3. 5 times negative 1/3 gives me negative 5/3. Then in order to do this, I have to have a 3 in the denominator. So multiply the top by 3. It gives me 6. I'm left with 11/3 equals negative 11/3. That is not true. So the solution x equals negative 1/3 is extraneous.